In Learning Objective C, we're going to talk about the half-turn theorem. What the half-turn says, it is a 180-degree movement. So what they're going to do in this one is they're going to look at an original angle. In this case, it's right here. And then to the half-turn, what they're going to do is take that angle and add to it 180 degrees. Let me show you the notation. So this right here shows you they took 180 degrees and added it to the angle. So what they're going to do is investigate what happens to the cosine, the sine, and the tangent if you take, again, our original angle right here of theta, and we add on 180 degrees, are the cosine. What happens to the cosine, sine, and tangent values? Well, let's do the movement. The original angle here, let's identify that one in red. Let's do the new angle in blue. Well, to travel to this red angle right here, we're going to go right and up. To go to this one, we're going to go left and down. So we're doing directly the opposite on each of them. So what we're going to find is the cosine here, which was positive, will now become negative. The sine here, which was positive, will now become negative. The tangent means the slope of the line. Well, the slope of the original angle is right here. The slope of the new angle is right here. It's actually on the exact same line, so the slopes are the same in this case. So the theorem says this. The cosine of these are going to be direct opposites of each other. The sines are going to be opposites of each other, but the tangent is actually going to stay the same. Now, I don't sit and memorize these theorems. I personally just sketch the scenario. Sketch the original angle, tack on 180 degrees, and notice the cosines are exactly opposite and the sines are opposite too. So let's look at this example that we did in the opposites theorem, but this time let's do the half-turn theorem. Reviewing what this means, the cosine of x is equal to this. Remember, cosine just means the x value. And again, maybe it would have been more clear if they said the cosine of theta equals that. It doesn't matter if they use a theta value here or an x. It means the same thing. So what that means is the x value of my angle is this. So remember, that's all I know about the ordered pair. So if the x value is that, means here's the x movement to the left. Again, we did say for this problem, let's have our theta actually be between 90 degrees and 180, because they typically clarify where that should be, which is quadrant 2. So if we sketch this angle, be going up about right here. So this right here is our theta movement. And I'm going to label the ordered pair up here so I can see it more clearly right there. Okay, the half-turn theorem. Let's do both cosine, or just the cosine. If they want to know the cosine of our angle plus 180 degrees. Okay, maybe they would have used the x, that's fine. It's common for them to use x instead of theta. Again, this theta here could have been x. All they're doing is they're saying, let's take the angle, here's the angle movement. So move the angle, which we've done, now tack onto it another 180 degrees. Fine, there's the angle movement. Now if you tack on 180 degrees, that would be a half of a circle, which is going to land me right about down here. So therefore we are seeing the original angle movement, which is in the blue, plus the 180, which is right here. That's where I land. Okay, let's travel to it. To get to the original angle, again, we had to go left 0.3 and up some amount. So to get to here, we're going to have to go right 0.3 and down some amount. So right 0.3 and down some amount. Well, they want to know what is the cosine of this new angle. It's right there. So the cosine value here is a positive 0.3. If they had asked me anything about the sine value, well, again, to get to this point up here, I would have had to go up a certain amount. To get this to one down here, I'd have to go down. So here their sine values are going to be directly opposite of each other. Now, if they had asked us about tangent, again, take a look at this particular line. The tangent of this is a negative downward sloping line, but so is this, the negative downward sloping line. The tangents on here are going to be the same thing, because it's just going to be sine divided by cosine, or this sine divided by cosine. Both of them are going to end up being negative tangent answers. Now, let's piggyback off of this example we did for the opposites theorem The one where we said the sine of an angle is 0.5. Let's see if we can find what is the sine of the angle plus 180 degrees. So let's resketch this. Remember, the sine of an angle means the y value, so we know that the y value here is going to be 0.15. So if the y is 0.15, we also clarified for this one, let's stick in the area from 0 degrees to 90 degrees. So that's the interval we're going to look at, so just quadrant 1. And here's the angle. So if I sketch that in, and I'm just going to label that ordered pair again right here. And this is the theta. So what this theorem says is take the original theta, so the blue angle movement right now, and add to it 180 degrees. Okay? So I'm moving the blue angle. Now if I tack on an additional 180 degrees from that, is going to land me somewhere over here. Well, if we talk about how to travel to the blue ordered pair is to the right something and then up 0.15. To the black would be left and down 0.15. So this is what I know is that the sine value is right there. So the answer here would be negative 0.15. Notice here again, the cosine here is going to be right. Over here it's left, so their cosines will be opposites. The sine here was up, here it's down, so that's why they're negative. Again, let's practice the half-turn theorem. Let's resketch this scenario. So the sine of an angle is negative 0.2, so we know it's this right here. Again, we clarified earlier in the example that we want theta to be between 270 and 360 degrees. So negative 0.2 is about right here. This is 270 to 360. So we're in quadrant 4. That's our theta movement. And that's this ordered pair right here. Now, to answer the question, here's what they want us to do. For the half-turn theorem, find the sine or the y value. Take your current angle that they have and add to it 180 degrees. So here's what we're going to do. Here's the current angle right here. And we're going to add on to that 180 degrees. So from here, move 180 degrees, and then we'll draw the angle, which will land us right there. So this was another 180 plus the current angle. Now technically, remember 180 degrees positive would be moving counterclockwise. The reason I showed my 180 degrees on here, which is really a negative 180 degrees, is because this initial angle here is a negative angle. So there's two ways you can sketch and get here. If this blue one's a negative angle, then I did a negative 180 to it. But I know it's going to land on the same line, so that's correct. Or what you could also have done is this. If this is a negative angle movement, let's say it's negative 20. Fine, if you land here, if you take this negative angle and you add a positive 180 to it, what's going to happen is you're going to move the negative number. Again, I'm going to guess this is about negative 20. If you add 180 positive to that, you're going to end up tacking on 160 degrees, which will still land you here. So when the angle that they give us is actually a negative movement, it's kind of a little trickier to see the adding 180, but you can go this way and do it. Fine, let's answer the question. Again, to land at the original angle here, in the blue, we went right and down negative 0.2. And to get to the green, we're going to go left and up. So I know that this is some left movement, but I know it's going to be up that amount. So what is the sine of my angle plus 180? It's a positive 0.2.